Hello, everybody. Welcome back. This is our fourth week of online algebra. Thanks for sticking with me. Let's get started. And I hope you all are ready to go outside, enjoy the sun, enjoy the waves. That's right, we're going to surf school. We're talking radicals. Specifically, we're talking section 10.2, simplifying radicals. Now we'll see that radicals and fractions have a lot in common, so let's get started with this start thinking. How can we rewrite 7/6? And how can we use that to think about how we might be able to rewrite square root of 20? Remember, the square root is the same thing as a radical. So, 7/6, how can we rewrite it? Well, we can rewrite it as a decimal. And that comes out to be something like 1.16. You can check that if you want to. But how else can we rewrite it? Well, we can simplify it, right? We can write it as a proper or a simple fraction. We can write it as 1 and 1/6. We can do the same thing with the square root of 20. We can write it as a decimal, and that decimal comes out to be about 4.47. But we'll be learning how to simplify them today. Simplifying is nice because it gives us a precise answer, right? You can go to a decimal at any point, but going from a decimal back to a simplified version is much harder. Simplified. And that's going to be 2 square root of 5. We'll figure out how to get that in just a second. Now, we have 3 rules for simplifying a radical. Rule 1 is the perfect square rule. Rule 1, the perfect square rule. And what that says is you cannot have a perfect square left in the square root. So no perfect squares in the square root. So something like the square root of 4. That is a no-go. Make sure that you have no perfect squares. Rule 2 is going to be a fraction rule. And what rule 2 says is you cannot have any fractions inside of the square root. So no fractions inside the square root. If you had something like the square root of 3 divided by 4, we have a fraction inside the square root. That breaks this rule. This is not a simplified radical. And rule 3 is a denominator rule. Rule 3 says you cannot have a square root in the denominator. So no square roots in the denominator. So if you had 3 over the square root of 7, that is a no-go. We have a square root in the denominator, and that's not simplified. Now let's look at how we fix each of these and make something follow these rules. We're going to go rule by rule here, starting with rule 1. Perfect squares. So let's say we are looking at that same example from the start thinking, the square root of 20. How do we simplify that down? We have a 5-step process. Step 1, divide by a prime number until you can't anymore. And remember, prime numbers are the ones that can't be divided by anything except for themselves and 1. So things like 2, 3, 5, 7, and so on. So we're going to rewrite 20 over here. We're going to put it at the top of a t. And we're going to start by dividing by a prime number. Let's start by dividing by 2. If we divide out a 2, we're left with 10. Can we divide out 2 again? We can. So we divide out a 2, we're left with 5. Can we divide out 2 anymore? No. So we finished step 1. Step 2, divide by the next prime number until you can't. So, finish dividing by 2. Let's try dividing by 3. Not going to work. So we divide by 5. And we get to 1. And that's our third step. You're going to keep dividing until you get 1 on the right. So we've finished step 3. Step 4 says any numbers that show up twice in the left row get to go on the outside, and you multiply all of those together. So 4 doubles on the left go outside, and they multiply. And then step 5, we take whatever's left, single numbers, stay on the inside, and they multiply together. So if you think about it, it's sort of like your middle school dances. All of the people who are partnered up, they all go into one area and they have their fun, and then everybody who's single just sort of stays off awkwardly on one side. Let's see how this looks for this problem. So we have a 2 and a 2. That's a double. They're going to go on the outside. What are we left with? We're left with a 5. 5 is single, so it's going to isolate itself from everybody else. Doubles go on the outside, singles go on the inside. Let's do some practice with this. Let's say you were given the square root of 432. Let's go through how you would do that. We're going to put 432 on the top of a t and start dividing. We're going to start by dividing by 2. Divide 432 by 2. What do you get? Well, put it into your calculator. You'll see it's 216. We're going to divide that by 2. That gives us 108. Divide that by 2. We're left with 54. Divide that by 2. We get 27. Now, is 27 divisible by 2? No. So we have to move on to our next prime number. Let's try dividing by 3. 27 divided by 3 gives us 9. We can divide 9 by 3 to get 3, and we can divide 3 by 3 to get 1. So we're left with 1 all the way over here. Now we're going to pair everybody off. We have 2 sets of 2's there, we have a set of 2's there, and we have a set of 3's. All of the pairs go on the outside, so this becomes 2 times 3. And that poor remaining 3 down at the bottom here stays on the inside. So this becomes 2 times 2 times 3, or 12 times the square root of 3. Let's do one more of these, looking at the square root of 300. So, if we put 300 on our t over here, start by dividing by 2, that gets us to 150. Divide by 2, that gets us to 75. Can't divide by 2 anymore, so let's divide by 3. We're left with 25. Can't divide that by 3, so we're going to jump to 5. Get 5, and 5 brings us to 1. Who are our partners? Well, we have 2 2s and 2 5s. So this is 2 times 5 times the square root of 3. Or this is 10 times the square root of 3. Now remember, or let's look at a second way to do this. If this makes sense to you, go ahead and use it. If not, this is tried and true. It'll work every time. We can also say that 300 is the same thing as 3 times 100. Or we can split that up so it becomes the square root of 3 times the square root of 100. What's the square root of 100? Well, that's 10 times the square root of 3, or 10 square root 3. So if you're comfortable with it, you can look for perfect squares and split them up and take the square root. Otherwise, just use the t-chart. Okay, let's look at a couple of harder examples. Make sure that we're all getting this. So let's say you're trying to look and simplify 2 square root of 45. We want to make sure there's no perfect squares in the 45. So we're going to put it on our t. Can't divide by 2, so we're going to divide by 3. What does that leave us with? 15. 15 is divisible by 3. That leaves us with 5, and 5 goes to 1. Now we have this pair that goes outside, but we also have this 2 on the outside. Oh no, what happens? Simple. All we do is we take the 2 and we multiply it by the 3. We take the 5 which was left over and we multiply it in there. So the answer for this is 6 square root 5. All right, 2 more slightly harder ones. Let's say you're multiplying 2 numbers together. So let's say you have 3 times square root of 5 times 2 square root of 10. What do? Well, we're going to multiply the insides together and multiply the outsides together. The inside goes with inside, and the outside goes with the outside. So 3 times 2 gives us 6 times the square root of 5 times 10, or 50. Now we have to do 50 on a t-chart. Make sure that there's nothing left in there that we can't pull out. Divide by 2, get to 25. Divide that by 5, we get to 5, and 5 to 1. So we have those 2 5s in there. This becomes 6 times 5, square root 2, or 30 square root 2. And one last one. This one is harder. We're going to include variables with it. So what happens if we're trying to take the square root of 20x to the 4th y cubed? Oh no, we have variables in here. Well, let's start with what we know. Let's start by doing 20. For 20, we can divide by 2, get to 10, 2 to get to 5, and 5 to get to 1. Now let's write out everything that we have left. So we're going to write out, we have x, we have x, we have x, and we have x, right? So this is technically saying we still have our x to the 4th y cubed. We're going to take out 4 x's, divide by it each time, and we're going to do the same for y. So we're going to have 3 y's. And now all we have to do is we just pair these up like normal. So we pair up the 2's, pair up the x's, and pair up the y's. All of those that are circled go on the outside. So this becomes 2 times x times y. And what's left over that goes on the inside? Well, we have a 5 that wasn't partnered, and we have a y. So our answer for this is 2x squared y, square root of 5y. So doing this with variables, pretty much the same. Just write them out, circle them, pair them off, and you're good to go. So that's how we get perfect squares out of the square root. What do we do for fractions? Our second rule said no fractions. So if we have a fraction, like if we have the square root of 36 over 25, What do? Well, remember, from when we were dealing with square roots before, we can split up a square root into the top and into the bottom. So the square root of 36 over 25 is the same thing as the square root of 36 divided by the square root of 25. And all of a sudden, oh my goodness, this makes sense. What's the square root of 36? Well, it's 6. And what's the square root of 25? It's 5. So that's our answer, is the square root of 36 over 25. Split up the square root and see if you can do anything more with it. All right, let's look at one that's slightly harder. Let's look at the square root of 20 over 9. We'll call this problem 2, problem 1. We're going to split this up so we get the square root of 20 over the square root of 9. And we know the square root of 9 is just 3, but what's the square root of 20? Well, got to go to our t-chart for that one. We've done this one enough that we know we can pull out 2 2's and leave a 5 in. So this becomes 2 square root of 5 over 3. That's how we deal with fractions. Split up the square root over the fraction and then do the square roots like you did with rule 1. All right, we're on to our final rule here. Final rule was no square roots in the denominator. So how do we get a square root out of the denominator? Well, we're going to multiply by whatever's in the square root on the top and bottom. So if we have something like 2 over the square root of 3. We have this square root in the denominator. We can't have that for this to be simplified. What are we going to do? We're going to multiply by what's in the square root on the top and the bottom. So we're going to multiply by the square root of 3 on the top and on the bottom. What does that leave us with? Well, on the top, we have 2 times the square root of 3. But on the bottom, the insides combine. So this becomes times the square root of 9. What's the square root of 9? It's just 3. So this is 2 square root of 3 over 3. The trick, multiplying by the top, or multiplying by the square root on the top and the bottom, gets rid of this. We're just left with whatever's inside to become the denominator. Right? Whatever's inside becomes the denominator. All right, let's see, a couple more of these. If we had 4 over the square root of 10, what would we do? We'd multiply by the square root of 10 over the square root of 10. And this becomes 4 square root of 10 over 10. Now we have one more step here, right? We have 4 and 10. We can cancel those out. We can pull a 2 out of both of those. So this becomes 2 square root of 10 over 5. Right. And let's do one last harder one. You have 3 over the square root of 20. I'm using 20 a lot here. Just makes our life simpler. So we could multiply by the square root of 20 over the square root of 20. But we already know 20 can be reduced. So let's try not doing that, and let's reduce this first. We'll take 20, we'll factor out our 2 2's and our 5, so this gives us 10, 5, and 1. This is the same thing as 3 over 2 square root 5. Now, when I said we have the rule, multiply by the square root in the top and the bottom, we're going to multiply by just what's in the square root. So we're going to multiply by the square root of 5 over the square root of 5. This gives us 3 square root of 5 over 2, and these two combine to just become 5. So our answer for this is 3 square root of 5 over 10. I have one more example here. Yeah, Noah. We're going to move on and let you all get some practice in. Make sure you're doing these. This is a new topic and it can be confusing. I want you to simplify. We have the square root of 60. Simplify square root of 4a cubed. Simplify square root of 25 divided by 4. And that square root covers both. And 7 over square root 12. Then I want you to multiply and simplify. 3 square root 7 times 4 square root 14. So go ahead and do these. Make sure you're pausing, working them through, and I'll meet back with you guys to explain them in just a second. All right, starting with problem 1. We have the square root of 60. Let's put 60 on our t. What can we pull out? Well, we pulled a 2 to get this to 30, a 2 to get this to 15, 3 to get this to 5, and a 5 to get this to 1. So we have 2 2's. Those are going to go on the outside. And what's left over? 3 times 5. So our answer for this is 2 square root 15. For this next one, let's put 4 up here. We know that 4 is going to be 2 and 2. And then let's write out our 3 a's. So what do we pull out? Well, we have those 2 2's and that a. This becomes 2a square root of a. For problem 3, we're just going to split this up. So this becomes the square root of 25 over the square root of 4. Square root of 25 is 5, and the square root of 4 is not 4, it is 2. All right, problem 4. Now we have something on the bottom here. Let's see if we can pull anything out. So we have 12. We can pull out a 2 to get this to 6, a 2 to get that to 3, and a 3 to get that to 1. So we have those 2 there, so this becomes, let's break this up. This becomes 7 over 2 square root of 3. We're going to multiply by whatever's left in the square root on the top and the bottom, and this becomes 7 square root of 3 over 2 times 3, or 7 root 3 over 6. Let's box these, make sure you know what our answers are. Then for this last one, we're multiplying and simplifying. So in goes with in, out goes with out. 3 times 4 gives us 12. Square root of what is 7 times 14? That's going to give us 98. So we have 12 square root of 98. Are we done here? Nope. We're going to have to make a t-chart, see what we can pull out. So 98 is going to be divisible by 2. What happens when you divide by 2? That gets you to 49. 49, not divisible by 3, not divisible by 5. Is it divisible by 7? Let's check. It is divisible by 7, so we're going to pull out a 7. What are we left with? 7. And 7 is divisible by 1. So we can pull out a 7 and leave a 2 behind. This becomes 12 times 7 square root of 2. 12 times 7 gives us 84. So our answer is this is 84 square root of 2. All right, that's your lesson on simplifying radicals. Remember those 3 rules. Can't have any square roots in the denominators, can't have a fraction in the square root, and we got to make sure we're doing those t-charts. Go ahead and do the homework.